Hey, Jam, have you ever wondered how antidepressants work?
I have wondered that, yes.
Well, so have our listeners, and so have I. And lucky for you, I don't have to answer that, because have you ever also noticed that there's somebody sitting right beside us?
I was wondering about that.
We have brought in a special guest, a guest expert, Claire, to teach us all about how antidepressants work today.
Awesome. Very cool.
Are you ready to learn?
Let's do it.
Yay! Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Claire edition. Okay, so we have brought in a special guest expert, Claire. And Claire, will you tell us what your expertise is in, what you do with your life, what makes you qualified to share it with us about how these things work?
Yeah, heck yeah.
Okay, great. Yay.
So my name is Claire Caballero, and I am a pharmacology and neuroscience PhD student at the University of North Texas Health Science Center at Fort Worth.
Whoa.
Nice. That's a mouthful.
It is a mouthful, but it makes me look really impressive. So
yeah, the more lines you have after your name on the email.
Yes, exactly.
Okay, can you pause real quick and tell us what pharmacology means?
Yeah, so pharmacology is the study of both how drugs affect the body and how the body itself affects drugs. So it's less about dosing drugs and like knowing how, like what you would need to prescribe a patient. That is included, but what I studied this past semester was more about how the drugs work at the molecular level.
Okay, nice. So it's so much chemistry.
So much chemistry, yes.
Okay, and when you say drugs, you mean like the ones that doctors prescribe, not like illicit ones on the street?
Well, we actually did have a module about misused substances. And I'll actually talk a little bit about it today.
Oh, how exciting.
One of the prescribed drugs I'll talk about is also a misused substance.
Ah, okay.
Great.
Fun fact. So, yes, a caveat, I'm not a licensed physician or pharmacologist. Felt like I should say that.
I say that a lot on the show. I'm like, I'm not a doctor. And then I was like, wait, now I am a doctor, but not that kind.
Yep.
No,
Yes.
I am working towards my doctorate, just like Melissa is.
Nice.
So, yeah. And I took very intensive courses over pharmacology and neuroscience this past semester at my school. So that's why I feel like I'm very well equipped to answer these questions, because I just got the information.
Yeah.
Yes.
Nice.
Yes.
Nice and fresh.
And I will say, so we obviously, Jim and I know Claire from like our own real life, but over the course of the semester, I would ask her questions and she would give such good, interesting answers. And I was like, I got to get her on this show. So, and also Claire, to take some of the pressure off you. A thing that we say a lot at Chemistry for Your Life is you're an expert, but that doesn't mean that you know everything. And all we can do is the best we have with the information we have at the time. So, you know, if there's something you don't know, you can just feel free to say it, you know? Experts know enough to be able to research the questions we ask, but they don't have to know everything all the time.
Yep.
So
Good.
you are totally an expert and totally qualified.
Okay, that makes me feel so good.
And I know. I also like realized when we started, I was a master's student, I think. But I had my master's, but I didn't. I was working on my PhD, and I had never called myself a chemist ever until this podcast.
Oh, yeah.
And Jam made me say it every week, and I was like, "This is so weird." And now I'm like, "Yeah, I'm a chemist," because of what he taught me. So
Yeah.
It did kind of feel like I was thinking from the very beginning, I'm like don't know anything about this stuff and I'm learning it. And I was thinking like, if I was just clicking, I'm a big podcast fan, we both are. I'm just clicking on a podcast and I'm a regular person who's not a scientist of any kind. I kind of want to know like who you are and like what your field of study is, you know?
Yeah.
Not that you should be like a walking, infallible, brain of chemistry knowledge that never does wrong, but more like, oh, can I like at least trust that this person knows how to, explain things, knows how to get the right information, knows how to research stuff and that kind of stuff. So I think I like things dumbed down in a way where like, oh, she chemist. I get it. She pharmacologist. I get it, or whatever. So
Yeah, no, and I was listening to your ADHD episode and you were like, I'm not a neuroscientist. And I was like, but I'm a neuroscientist, and I had never thought about myself that way until today. Like until I was like, oh my gosh, I'm a neuroscientist.
We should have made you be like, I'm Claire, and I'm a neuroscientist / pharmacologist.
Yeah.
Okay, well, Claire, are you ready to teach us a lesson today?
Yes, I am.
Okay, tell us what you're going to teach us.
Sweet. So I'm going to talk about drugs that treat depression and anxiety.
Okay.
So I feel like, everyone knows somebody that takes one of these drugs.
Yeah.
Yes.
So I feel like it was important to talk about all of them.
I take one of these drugs. If you don't know anyone in your in-person life, now you know someone in your digital life.
I also used to take some of these drugs.
Yeah.
So it's like everyone knows someone.
Yeah.
Now with this.
Whether you know it or not, you know someone.
So first, we'll look at some basic neurochemistry. So in your ADHD episode, which everyone should go back and listen to, it's very good information. You did a great job.
Thanks. That's nice to hear from a neuroscientist.
It was so good. I loved your analogy. I think you used like a truck analogy because your husband. Yeah,
that was good.
Yeah.
Yes. So we'll go a little bit into that, some neurochemistry, neurotransmission, just to get the background of how these drugs work. And then we'll go into all the classes of the drug.
Okay.
We'll look at why they work, why we prescribe some and not others more often. And how they can make you feel yourself again whenever you have depression or anxiety.
Yeah.
So,
oh my gosh, I'm so excited.
It's going to be good.
Let's get into it.
All right. So I won't go into a lot of the structural chemistry. That's your area of expertise. And in that episode, you did cover like what the structures of the neurotransmitter is, specifically dopamine. So
nice. I'll
I'll leave that to you and to the listeners to go listen to that episode.
Good job, past me.
So do you guys like analogies?
Oh,
Okay.
yeah. Around here, we love analogies.
Okay, so I tried coming up with an analogy. I had to look this one up because I was like, neurotransmission analogy. And then I found one. I remembered that we talked about it in our class. So I was like, oh, this is perfect. Except I have to explain the analogy first and then it goes in.
That happens a lot. Yeah.
Yes. So do you guys know how a telephone operator works or / it did work back when we had telephone operators?
Yes, I think I do. No, I feel like I've watched enough movies where this was done, but also we talked about it in some of my radio classes and the early technology of transmitting stuff across.
Now we have another expert.
Yeah. I mean, in this area, it'd be more they told us the tiniest amount, but yeah.
Well, the tiniest amount I'm about to tell you is the tiniest amount.
Perfect.
It's so small.
Perfect.
So basically from what I know, you would make a call. That call would go to an operator, and the operator would have this giant switchboard thing that they sat in front of, and they would ask who do you want to connect to, and then you would say, and then they would take the cord that was attached to your landline, and they would attach it to the jack that was attached to that person's landline.
Nice.
So they were literally connecting it was please wait while I connect your call. They were literally connecting
your cord.
Your cords. Yes.
So that's when you see the person with the,
yes,
the little, I feel like she has a headphone or something.
Because they would take multiple calls at once.
Yeah.
And actually the analogy works really well for this actually.
Okay, great.
So then whenever the call's over, the operators, she unplugs it. It could have been a guy, but I think mainly it was females that were operators.
Women in movies. Yeah.
Exactly. Okay, so imagine that you have a neuron that wants to send a message to another neuron. So a neuron wants to make a call.
Okay.
So this occurs at a place called the synapse, and the synapse is the space that is in between two neurons.
Okay.
So the initial caller is going to be the electrical message that the first neuron sends down its own axon, which is the branch of the neuron.
Okay.
So this is that's the call. That's them picking up the neuron picking up the phone and dialing.
Okay. This is taking place. You may get to this. Is it in our brain? Just only in our brain?
No, it actually is in your periphery too, but it's where your neurons communicate with your muscles to make your muscles move.
Okay. So anywhere there's a neuron, this can be happening. Okay.
Yes.
Okay.
Wow.
Sorry, keep going.
Yeah. So that call, that first caller, will contact our operator, which is going to be what we call the presynaptic neuron.
Okay.
So that's just the neuron that it comes before the synapse.
Okay.
It's going to be one that's sending the message.
Okay.
So the operator is going to connect the call by releasing a neurotransmitter. And that neurotransmitter will go and bind to the postsynaptic neuron, which is the recipient of the neurotransmitter.
Okay.
So think about it like the operator is the neuron saying like, okay, I'm going to go plug in my call or this call to the recipient. And that recipient is this postsynaptic neuron.
Okay.
Yeah.
Can I ask a question,
Yeah, go
or
ahead.
are you in the flow?
No, go ahead.
So the neurotransmitter is like a chemical connection,
Yes.
right? Okay.
Yeah, and that's why
Okay.
neurons are so cool because they have electrical and chemical transmission happening. So the electrical
Wow.
triggers the chemical,
Wow.
and then so in the presynaptic one, right?
Okay.
And then the chemical binds to the postsynaptic neuron,
Okay.
and that triggers another electric one in like the second neuron. And this is all happening in like milliseconds.
That is
Crazy.
Wow.
It's crazy.
It's crazy that our brain knows how to do that.
yeah.
Yeah.
Okay.
Yeah, and I could come and talk about like action potentials in the electric side, but that's just a whole nother beast.
Yeah. Electricity stuff is like,
Oh,
yeah.
yeah, it's cool, but it's so much along with this
Yeah.
chemistry stuff. So then the neurotransmitter is going to bind and do its action. We'll talk about the different kinds of actions that different neurotransmitters can elicit.
Okay.
But then after the call is done, the operator unplugs. So he would unplug the phone. And in this case, the presynaptic neuron, who was our operator, is going to take back up the neurotransmitter
Okay.
back into itself
Okay.
Okay.
through various neurotransmitter transporters. And there's a specific transporter for every neurotransmitter.
Okay.
Okay.
This transporter is very important for these drugs.
Okay.
Okay.
So after the neurotransmitter has done its thing, it gets basically sucked back up to the neuron that released it.
Okay.
And therefore, no more response is happening now.
Okay.
Okay.
So, does that make sense? Any questions?
I think
I
so
think
far I'm tracking, but
my question is, and you might get into this, so you
Okay.
can just tell me to wait. What types of messages are we sending?
Oh, yeah.
I guess like the person who gets the call, what are they supposed to do? Are you going to talk about that?
Yes, I was going
Okay.
to talk about
Okay.
which
Okay.
neurotransmitters do what.
Okay. Great. Great.
this is what it's
Awesome.
like to be on
Yeah.
this side of it because usually I'm like, I think this will make sense to me later. Like,
Yeah.
I'm like, I'll hang on to this for now and hope
Yes.
that I figure it out.
Okay, I'm tracking with everything you said. I'm just wondering about
Yes.
the context
Yeah.
it's inside of. You know what I mean?
Yes.
Totally.
Yes. Okay. So each neuron really only makes like one type of call. So like there's like what we call like dopaminergic neurons. So those release dopamine. There's
Oh.
serotonergic neurons, which release serotonin.
Okay.
There's GABAergic neurons, which release GABA. So these are all
Okay.
neurotransmitters that I'm about to talk about. So
Okay, interesting.
yes, yes.
Wow, this is so
Yeah.
exciting. I love
It
learning.
is. So there's a couple different classes of neurotransmitters. So amino acid transmitters, these work to like directly modulate like how the neuron's going to produce an electrical response.
Okay.
Like they like directly make it basically.
Okay.
There are modulator neurotransmitters, which are like your monoamine, so dopamine, serotonin, norepinephrine. Those are work to modulate how the neuron responds to
Okay.
amino acid transmitters.
Okay.
Neurotransmitters. So that's just a little caveat. That's unimportant as to what they do, kind of thing.
Okay.
So, in anxiety, the main neurotransmitter at work is GABA, which is gamma aminobutyric acid. That's what that stands for.
Okay.
So that's your main inhibitory neurotransmitter in your entire central nervous system.
It's an inhibitor.
Yeah. So
Inhibitory.
what that means is when it binds to the postsynaptic neuron, when it binds to the neuron that receives it,
Yeah.
it prevents that neuron from firing, or it makes it less likely that that neuron is going to fire.
Okay.
So it's like a calming effect. You know, neurons are always like
Uh-huh.
kind of firing crazy. GABA works to kind of chill it out.
Okay.
Okay. So
Yes.
your brain's like, you need to calm down.
Yeah.
Yes.
It sends this out. Okay.
It also inhibits the release of the hormone that stimulates the hormone adrenaline.
Okay.
So there's like the pituitary gland sends out a hormone that stimulates the release of adrenaline.
Okay.
So GABA prevents this. It
Okay.
inhibits this. So it's
Okay.
like working twofold to kind of chill you out.
I see.
It's like
Okay.
you don't
Chill you
take
out.
these calls and you don't make this thing that's going to make you have an adrenaline response and
Exactly.
freak out.
Exactly.
Okay.
Yes. So in people with anxiety disorders, there's a dysregulation of this GABA.
Okay.
So there's either decreased levels of GABA or there's like a mutation or like a alteration of the receptor, and especially in the emotional parts of your brain, which is called the limbic system.
Okay.
So, which makes sense. A lot of times anxiety is like it's like a misrepresentation of things that are happening to you, right?
Yeah.
Like you think of, I know when I'm anxious, it's like I freak out about things that I really shouldn't be freaking out about.
Right. It's not like it's a rational response to like, it's not like your life is being threatened, like you're at the very edge of a cliff. That would not be anxiety in the way we think of it. That'd be just fear or like
Yeah.
Yeah.
a fight or flight kind of thing. It's more like a response to circumstances and situations that aren't necessarily like you're about to die, but it feels
Yeah.
like you are.
Yes. Sometimes it can feel like you are.
It feels like, yeah, exactly.
Yeah, exactly. And those are the same, it's in the same parts of the brain. And that's why it kind of feels like that,
Okay.
because those are happening in this limbic system. There's several structures in there that I was working in. So yeah, that's what GABA does. And anxiety is
Wow.
also influenced by the monoamines, but it's not as well understood. So I'll get a little into that. But GABA is like for anxiety, GABA is kind of your main issue.
Okay.
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 So then there's the,
Wow.
I know, right? There's
It's like
gonna
next
be-
time I'm anxious, I could just be like, brain,
make more GABA.
I'd be
you
like,
just, I know
GABA,
that you just aren't getting
GABA.
the GABA that you need.
Yeah.
Exactly.
Yeah.
So there's the monoamine deficiency theory. So this is now for depression. So the
Okay.
monoamine deficiency theory says that the underlying pathology of depression is that you have decreased levels or depletion of your monoamines, which is dopamine, norepinephrine, or noradrenaline. That's
Okay.
the same. That's the same neurotransmitter, and serotonin.
Okay.
So those are your three that are important.
Okay.
So dopamine, everything. It does everything.
Mhm.
It's movement, motivation, reward, learning, memory. A lot of your executive functions. You talked about this in the ADHD episode, which is very
Oh,
good.
I know. I know about all those things that dopamine's supposed to do.
So in people with depression, it comes very naturally. It's like a lack of dopamine manifests through like you're not very motivated. Things aren't as rewarding as they used to be. Like food that you used to like is not as stimulating as it once was. You don't want to exercise. You're not motivated to. It's not rewarding anymore. It can be. You can have like brain fog or like memory fog, right? Because it's harder to form memories because dopamine is very important in the formation of memories.
It's literally harder to form memory. Wow.
And I'm sure learning memory, that's great. Like mechanisms are not even well understood. So
Yeah.
who knows what dopamine's even doing? But it is a player
Yeah.
in there.
Yeah.
So it's not hard to see why dopamine can like cause these lack of dopamine can cause depression.
Yeah.
Yeah, you're telling me.
Wow.
So then there's norepinephrine, and actually norepinephrine is the direct like derivative of dopamine. It's like it comes right after dopamine. There's just a I can't remember which group. Let me scroll down.
Like one little functional group that's different. And our listeners know what functional groups are.
Yes. It's a hydroxyl group
Oh.
that's added.
I sometimes call that an alcohol group. Do you know what atoms make that up, Jim?
Oxygen and hydrogen.
Yes. Good job.
I was like, that was the first like knee-jerk instinct. But I was like, no, I need to think about it a little harder. Like,
No, that's right. Sometimes
I've got two scientists sitting right here, and I need to get this right.
Sometimes I call it an OH group
Yes.
so that you
Yes.
just remember that it's oxygen, hydrogen. But
Yes.
yeah.
It's an alcohol group. Yep. So norepinephrine, dopamine, very closely related. They're basically the same molecule. There's just an OH group on it. So it's involved in motivation, reward, attention to stimuli. So like your attention to things. So it's not as studied as dopamine in depression. and anxiety, but drugs that like target those receptors help with those symptoms. So it definitely plays a factor. It's just like, what factor?
They don't know yet. They just know it helps.
Yes, exactly. And then the most studied neurotransmitter in depression is serotonin. So serotonin is important for sleep and wakefulness, appetite, mood, pain, and reward as well. So those are all affected in depression again.
Yeah.
So not hard to see why lack of serotonin would cause depressive symptoms.
Yeah, that makes total sense. It's like essential to so many aspects of just getting through a day in the life of a human being.
And
it's
if
like,
you don't have enough.
Yeah. It's interesting how like there's so much we don't know, but it's clear that like, oh, this is so obviously an important part of some parts of our brain that not knowing how every part of it works isn't that necessary to still know that it's just super important. And I'm guessing it's probably possible to tell if your brain's not making enough of it because of those effects.
Yeah.
Yeah. And it's hard to look at it real time too. A lot of times we look at neurotransmitters like in what's called like ex vivo, where we take like tissue from an animal and look at it outside of its like host system. Or you look at it like in vivo, so you're looking at like a cell culture where it's basically like you're growing cells in a plate. So it's not in like a human brain.
Right.
So it's a lot harder to see. You can use like MRIs and you can use imaging systems to look at it, but it's just not as good as like directly measuring the levels inside your brain.
Never thought of that. Like you literally can't, there's no way to watch it happen.
Yeah.
Yeah, that's
tough.
crazy.
So it's really amazing that we know as much as we even know.
I know.
Mm-hmm.
I sometimes get that way when I'm learning about the very beginning of chemistry. I'm like, how did they figure out about atoms and electrons? They couldn't even see them.
Yeah.
Yeah.
I'm like, how do,
Yeah.
It's so weird.
Yeah. Scientists are really smart.
Yes. Yes. So yeah, the mechanism of serotonin and anxiety, again, less clear. But when you give drugs that target those systems, it helps. So
Yeah.
it obviously has something to do with anxiety.
Yeah.
So it seems like anxiety is just a little more, from what I saw, it's a little more like less clear. It's like less clear than depression. From what I saw. I don't know why.
Interesting.
Yeah.
Maybe just harder pathway to nail down.
All right, you guys ready to learn about some drugs? Any questions before we go into drugs?
I actually feel like this could be a good time for Jam to do. If you want to, we can do it together.
Oh, yes. You're
like a teach back.
Yes.
Okay, yeah, let's do it. Maybe I'll try to start, and then I'm already, some of the very particular wording is already fading.
It's okay.
So that
it's all right.
I know that way
it's
too.
very, yeah.
Yeah. So very important basic things in our bodies. So let's say I wake up in the morning, which I do every morning since I've been born. I've been doing that. And
sometimes until the afternoon.
Yeah. It's just one of those habits I have. Like every day, at least once a day, I wake up, sometimes twice. And
sometimes twice.
But then these things start working in my brain. Obviously, our brains are always working when we're asleep. But like the things we think of, like, oh, I need to get ready. I need to get my stuff together. I need to, all these things have to work. And so at the very, very individual, very microscopic level of things happening in our bodies, it is messages needing to be sort of sent, right? To get these things going. And that would happen with you said it's who's the one who's placing the call? Who's going to end up placing the call?
Presynaptic neuron is what
Presynaptic neuron.
Yes.
So that's the person that is wanting to initiate these things and send the messages. They send out their arm.
They send out neurotransmitters.
Okay.
So yeah.
They send out chemicals.
A chemical, yes. Okay. And the post-synaptic neuron is the one who receives it.
Yes.
And that post-synaptic neuron releases something as well because they're told to, or
yeah, I didn't really talk about it, I guess, but they do. So these neurotransmitters are binding to receptors on the postsynaptic neuron, and that causes things inside of the neuron to occur.
Okay.
So it could be release of certain things inside the cell, but it's basically just like a cascade of like molecules that go crazy to induce a response.
Okay.
Or not reduce a response, like GABA. Remember, GABA doesn't allow neurons to fire.
Right.
But that is crazy. That
I know.
And then that equals a person.
Yeah. And they're happening so fast. So it's like you said, like things like movement, even just like moving our muscles, or like being motivated to do something, or or being told not to not sort of freak out or whatever, to chill. Basically, the most essential things about thinking and moving and feeling of human beings.
Yeah.
What else do we should talk about? What am I missing?
So then you talked about how there's like sort of two classes, right?
Oh, yeah.
So I can take over this part because I think it's a little more chemistry.
Yeah.
So one was the monoamines, right?
Yes.
And the monoamines are like dopamine, which we talked about a lot. And what monoamine means is an amine is a functional group, which we've talked about a lot before. It's just a collection of atoms that act in a certain way. So like nitrogen, 2 hydrogens is an amine group. And monoamines have one of those. So do they act similarly?
They do, yes.
Because they have that similar amine
Dopamine
group?
and norepinephrine work especially similarly since they're basically the same thing. Serotonin's a little bit different because it's it's like made in a different way.
Okay. Yeah. And then the other type is the GABA. But is that a class? Or
It's amino acids. There's a couple others that also work.
Okay, so amino acids, typically they're a bunch in our body. They're like the building blocks of proteins. We've talked about those before too. They're the beads in the necklace of a polymer, you know, the individual repeating units. And usually they're called amino acids because they have an amine group and some kind of carboxylic acid group with like an alcohol and hydrogen or oxygen, hydrogen. So those are other functional groups that are consistently present in amino acids. The carboxylic acid gives it the acid. The amine gives it the amino. So that's a different class. And the only one of those we talked about was the dopa, right?
GABA.
Oh, GABA, right. And GABA stops things from happening while the other ones seem to help things to happen.
Yes.
Okay.
Yes.
And those teamwork.
Dude, it's hard on this side.
Those two, so those are that category we're talking about of serotonin, dopamine, norepinephrine, and then GABA. Those are the transmitters.
Yes, those are those are like molecules that are being sent and then binding and then coming back.
Got it.
Yeah.
The message being sent, the phone call being placed kind of thing. They are
the phone call.
They are the phone call.
They're the wires that get connected. They're the wires themselves.
Yes.
Got it.
There's so many there's a lot more neurotransmitters that kind of work in our brain. But these are the ones that are important for depression and anxiety.
Yeah.
So what I'm picturing in my mind, and maybe I've like seen this in a textbook or something, is the first side that's placing the call sort of sends things out across like an empty space.
Yes, and that's what the synapse is. The synapse is really nothing. Like it's not any
empty
like it's not
space.
any substance. It's just empty space.
Got it.
And it
The
sends the
synaptic cleft
chemicals.
is also what we call it.
Sends the chemicals across that. Is there like some kind of fluid there?
Yeah, it's called the interstitial fluid, I believe.
Whoa.
I don't remember that.
Okay, that's fine.
And there might be some cerebral spinal fluid in there as well.
Okay.
That's
Whoa.
like giving nutrients to the neurons. I don't remember.
I was just thinking.
That's what I think. So if anybody wants to correct me,
I love using that line.
Yeah.
I was just thinking for the chemicals to move. It would.
They can't. Yeah, because and also if there was no like fluid or like I don't think our brains would be really dry, almost like a bone even. But you know our bones aren't dry either. So
Right.
there's liquid around your bones. Don't know about that, but I know there's.
Those are wet bones. You know what I'm saying?
Ew.
I was thinking like, what if you were like, whatever you asked if there was empty space, just like the thought that popped in my head was, what if Claire was like, yeah, there is some stuff between there. We just call it goop. It's like everything else is very technical, knowing the exact, things. And then she's like, yeah, but that stuff we just call it goop.
We just call it
like,
goop.
Just nothing.
some sort of something, and it's there.
Okay. Cool.
And then one thing that you guys didn't really miss, but it is important that they get taken back up.
Oh, right.
that's
Right.
Yes. By these transporters that are specific for each single neurotransmitter. They have a different one for each neurotransmitter.
There's little transporters whose job it is to take things. Like, do they kind of like deliver the supply to the?
Yeah, but it's like they're taking it back. It's like the unplugging. So it's like they're like, come back.
Into the call.
They facilitate the
come back to me.
unplug.
Yes.
Okay.
You did talk about it in your ADHD episode because that transporter is very important for the pathology of ADHD.
I maybe should have listened to that episode again because
Me
that's been,
too.
what, 2 years now?
Yeah,
Me too.
it was
Yeah.
2022.
Yeah.
Now are you guys ready to get into drugs?
Let's do it.
Yeah.
Oh, good. Okay.
We're already getting. We're already getting into
Yeah, and I
drugs.
just present like.
Here we go.
Let's
some-
just take this out of context.
There's that. Have y'all watched 30 Rock? Either of you guys?
No.
Okay, there's just this one scene where this doctor becomes a kind of recurring character, and at one point at the end of like an appointment, he's like, "Now, would you like any purples, blues, greens?" And he's like, "I even got some reds in from Peru," and it's just like calling drugs by their color.
I like
and this
that.
is off handing them out, and it's like that seems like that should be a big red flag. I don't think I should be seeing this doctor.
All my drugs are just blue. Every drug that I take is blue, which is not always helpful. But they're different sizes.
That's
it's like
good.
allergy medicine.
So as long as you're wearing your glasses, it might.
Yeah, that's all I need, just my glasses.
Me and my classmates would joke because in my neuroscience class, when we talked about like the sensory systems and the motor systems, we did like a hands-on activity for it, and it was really cool. And we were joking that like in our pharmacology class, we should also do a hands-on activity. We need to know how these drugs work.
You need to experience.
Yeah.
Yeah. No, exactly.
Yeah.
All right, let's talk about
All right.
drugs.
Let's do it.
Okay, so I'm going to talk about 4 different classes of drugs that are commonly used to treat depression and anxiety, and then I got
Nice.
2 bonus ones
Okay.
that can't really be put into these classes.
Okay.
So I'll give some examples. I'll probably just give the brand name because that's what people are familiar with. But a lot of these drugs there's multiple brand names for the same drug.
Okay.
So
I see.
that's a big pharma. That's a whole nother conversation.
Oh, I would love to hear that,
And we
but
also-
not today.
Also, in my class, I wish I remembered, we talked about like the naming conventions of drugs, and that was really cool too.
Yeah.
So
That's cool.
I can come back and talk about it one day.
a
maybe.
lot of them sound like chemistry words, but they're not. And that drives me
true.
crazy. I'm like, it's
It's
like
true.
you're almost using a chemistry language, but you just really miss it.
And some of that is on purpose. And a lot of times if it's a drug of the same class, they have to end in the same letters to like distinguish them as drugs of that class.
Uh-huh.
But sometimes they don't follow that rule, and like there's a whole thing, and like you have to present 3 names to this committee, like
Wow.
international committee.
oh my
and
gosh.
it's kind of crazy. And then
Wow.
brands can go crazy.
I think we
Yeah.
just need to give Claire the rest of this podcast so
Yeah.
that she just take over and she can just teach us all these lessons
Yep.
about big pharma.
Maybe.
She's like, I'm open.
I have opinions about big pharma. Okay, here we go.
All right, let's do
Okay,
it.
so our first one is our most common and probably what everyone is familiar with. These are your SSRIs. The SSRI stands for selective serotonin reuptake inhibitors.
Okay.
Okay.
So Melissa, I think, connected it.
Yeah.
So your examples here, this is going to be Lexapro, Paxil, Zoloft, Prozac. So a lot of times I have like a lot of friends that take that. I used to take Zoloft. So this was
Me
something
too.
very familiar to me when I learned about it in my class.
Yeah.
And so it treats basically every type of anxiety. So generalized anxiety disorder, which is GAD, seasonal anxiety disorder, which is SAD. That is the
Oh.
name.
Dang.
It can treat panic disorder, OCD, PMDD, which is premenstrual. I don't remember what the DD stands for, but it's like a dysregulation that is related to the menstrual cycle.
Yeah.
PTSD, social anxiety. It can also treat major depressive disorder, which is the clinical term for depression. Those are the FDA's indications for this drug.
Okay.
You can also prescribe drugs that are known as off-label. So that means they can be prescribed for these things, but the FDA has not said, hey, you can use this drug for this thing.
Got it.
So body dysmorphia SSRIs can treat that. They can treat binge eating disorder and fibromyalgia. Those are some things that they can
Wow.
also treat. So
Okay.
Got it.
it's a very good drug. These
Yeah.
are very good drugs.
Yeah.
So how they work. So like I said, there's that transporter that takes serotonin back up, right? So what this drug does is it inhibits that transporter.
Okay.
So that serotonin cannot be taken back up and it stays in the synapse longer. So that means it elicits more responses. So like you can think of it like serotonin comes off the receptor and it's like, okay, it's time to like be done. and then it goes to the transporter, and it's like, oh, I can't get back in. So then it just goes back to the receptor, and it's like, okay, I'm gonna do more work.
Yeah,
I see.
Exactly.
It's like if the transporter is like maybe a truck where like, you know how you put what's that thing down, the gate at the back down, so people can get in the truck bed. It's like, nope, the truck bed's still closed. You can't come and get in, and I can't transport you.
Yes, exactly.
You can't be transported in this vehicle. The doors are shut. The gate's up. You can't get in.
Exactly. So here we're not actually directly increasing the levels of serotonin. Actually, all of these, you're not like directly increasing the levels. Like you're not increasing production of serotonin. You're just making it do more work. Right. You're making it work more for you, basically.
Interesting.
What you already have, you're making it work.
It's so crazy because like this would not be the way I would think just by guessing, of course. I would never think this is the way they work. I would think it either is serotonin or is whatever specific thing you're wanting more of. It is that just putting more into your system, or it's like making your body make more, you know, whatever. Like that seems like a way that you know, these drugs work or whatever. It would not have occurred to me to be like, no, it's not making more. It's not giving you more. It's just making what you already have be available longer or out there working longer.
Yeah.
That's so fascinating.
And there is a reason why you can't just give serotonin or dopamine or many neurotransmitters.
Which apparently we asked this in the ADHD episode.
You did. You were like, I wonder why you can't just give dopamine.
And we've been sitting right here wondering that for 2 years, Claire, and you didn't tell us. Kidding.
I do wonder that every once in a while.
So there's a barrier between your brain and the rest of your body called the blood-brain barrier.
I've heard of this.
I've heard of it too.
It is very selective, which makes sense. You don't want unwanted things to come in. The brain's very important for your functioning. Right. And you don't want things that you like to go out, like your neurotransmitters. So pretty much all your monoamines for sure cannot cross this barrier. So if you give the drug, you would have to give it directly into the brain. No one, but you have to you would have to open your skull and put it in there.
Right.
No one really wants to do that.
No.
And so if you take it like orally, it goes through like your digestive system, and then makes its way into the bloodstream to go to all the parts of your body. That's another fun fact. Drugs don't know actually where to go. They go everywhere. And I learned that this year too. I was like, I always wondered that. It's like, how do drugs know where to go?
It's like,
they don't know where to go. They go everywhere, and then they do their action wherever they can.
That makes so much sense.
Yes. And it makes sense when you think about it, but I was never told that.
Right.
Yeah.
So if you took just dopamine orally, because nothing can cross your blood-brain barrier, those monoamines, because they would just be leaking all out over your body, that'd be bad. So then they wouldn't be able to cross up into it either.
Exactly. So you have to find another way to make serotonin do what you want it to do. So that's why you can't. And that's for a lot of brain disorders. It's a lot of neurotransmitter level problems. So they've had to be very creative in how they've made their drugs, so that because you can't just give more of it.
Neurotransmitters.
Right. I know.
Wow.
I know.
Gosh, you're so smart.
I just learned this all this year. So this is new. This is all fresh in my mind.
Yeah.
We'll see if I know this 2 years from now.
Honestly, I think grad students are sometimes the best people to learn things from because they're learning it so fresh and they're like, let me explain every detail of it to you. Whereas like sometimes when I go to conferences and the professors who've been doing it for a long time are presenting something, I'm like, I'm not tracking. This is really confusing. And then I go to the graduate student symposium and I'm like, yes, thank you for explaining that.
Yes.
So,
and the chance that there's like, obviously in this case, some of this stuff has been known for a bit, but like if there's anything just more current, you know, it's been slightly more detailed than it used to be or whatever. It's like, okay, well, people who just learned it are going to
I'm going to know all
might
of
know
it.
it. Yeah. That's
exactly.
awesome.
So SSRIs, they work pretty well. Like they have what we call efficacy. Efficacy is the like maximal response that a drug can produce. SSRIs have pretty good efficacy and they have a minimal like side effects. So that's really good too.
Yeah.
Like, obviously you don't want adverse effects to happen. There is an increased risk of suicidal ideation in patients under 25 for taking SSRIs. So,
can you tell us why?
No, I don't know. I don't know why.
They might not know.
If this is just speculation from my part.
Yeah.
But I think
we call this chemistry off the cuff.
I love it.
Neuroscience off the
Neuroscience
noggin.
off the noggin.
Yes, that's good.
Oh my gosh, that was
Also,
so
it's gonna be
witty.
an in. You were already there before I could. Yeah, that's perfect.
But I think like, because you always hear that your prefrontal cortex doesn't develop until you're 25, right? There's still a lot of things happening in your brain that like developmentally
Right.
up until that age. So maybe messing with these levels, even though you're not directly producing, you are like messing with it in the synapse.
Right.
Maybe that it's just too much dysregulation for these patients. Even though I took Zoloft when I was under 20, I am under 25, so I was taking it.
Yeah.
And because of this is called a FDA black box warning. So I'll mention this again for a couple of other drugs, but this is the most serious warning the FDA can issue for a drug, and it's because it either can cause serious injury or death. So SSRIs, even though they're really safe, they do have an FDA black box warning.
Got it.
Yes, but again, very safe. Like if you are very careful and you're taking it as your doctor prescribed, and your doctor is good at and telling you what to do, pharmacists good at telling you the side effects and such, you shouldn't have any problems at all.
Okay.
Yeah.
I'm writing down questions as we go. I have so many.
Oh,
this is so fun.
Very smart.
It is. And then another fun fact, it can be 6 weeks. It usually is 4 to 6 weeks before SSRIs start to take effect. I also don't know why.
That was one of my questions.
Probably just because like all SSRIs can only be taken orally. You can't inject them. And when drugs are taken orally, they go through what's called first pass metabolism, which means that your GI tract and your liver metabolize some of the drug. And this often results in some of the drug not being effective. Like it doesn't work.
Yeah.
So maybe the first pass effect of these SSRIs makes it to where you have to be continually taking it for 6 weeks to reach the concentrations in your blood for it to work effectively.
I see.
That's my thought.
Yeah.
That makes sense.
Yeah. But I don't know why it's 6 weeks for SSRIs and not for other types of drugs.
Yeah. That's so interesting. I've heard on the other side of like a friend of mine who was taking those, and I think was taking a certain amount, and so had gone through that 4 to 6 week period, and then the dosing was upped again later, and had to go through that again, and was just kind of explaining that experience, just the subjective experience of it being like very odd, and I don't know. That's so interesting to hear about on the like actual in the body affecting kind of things. Like, oh, that kind of makes sense. I guess you would need to, like, you were introducing something different, and I guess it maybe would be a little weird to expect it just to like instantly change things.
Because drugs are always going to be like, they're going to be metabolized. So you're going to have like these like, this like wave basically of concentration. So you like always need to be supplementing to get it at a constant level in your body.
Right.
Yeah. So that's why you should take your drugs when you're told to take them.
Oh, yeah.
Because otherwise it's going to mess up. I mean, when I took Zoloft, I wouldn't take it every day at the same time. But that's why it's recommended to. Yeah, it's recommended to. It's not going to like hurt you that bad if you don't, but recommended for optimal efficiency and effectiveness.
Right.
Fascinating. Okay.
Yeah.
So that's SSRIs.
Okay.
Yeah, that's the most prescribed one. Again, very safe.
Yeah.
And very efficacious.
Okay.
Next one is tricyclic antidepressants. I didn't look up brand names for this. Let me do that real quick.
While you're saying tricyclic, while you're looking that up, I'm assuming that means there's 3 rings in the chemical structure.
Whoa.
So my guess is a lot of times you can have like, if it's a carbon-based molecule, which a lot of these are, you can have 6 carbons like in a ring. Sometimes 5, 6 is really the best. And if you have multiple of them, they're like that bicyclic or tricyclic. So I'm guessing they have 3 rings.
Yes,
in them.
they do.
Are they fused rings?
I'm pretty sure, yes.
Yeah. So
from what I remember on my slide, like the picture that we were shown, I think they were fused.
If you could imagine like the best, I mean, if you could imagine like a honeycomb where they have like hexagons, you know, if you just imagine 3 of those hexagons right next to each other, that's sort of like the chemical structure of like fused rings together.
That's it. Yeah. Okay. So indications of depression, like that is pretty much all the FDA says you can use it for.
Okay.
It can also be used for migraines, insomnia, anxiety, and fibromyalgia. Those are
the
those
off
off labels.
Okay.
Got it.
Yes. So they're very useful and they work pretty much the same way as SSRIs do. They block the reuptake of serotonin, which allows serotonin to stay in the synapse and do what it needs to do.
Huh.
Yeah, and they bind to some other receptors that give them some other kinds of effects as well. But they are a lot riskier. Like there's a lot more side effects
Interesting.
with these drugs. And it has what's called a narrow therapeutic index. So the therapeutic index of a drug describes like the dose that you need to get a therapeutic effect.
Right.
Versus the dose that you need or not need, but the dose that elicits a toxic effect. So what you do is you divide the toxic effect, like dosage divided by the therapeutic effect dosage, and you get this number.
Okay.
The higher the number, the better. It's great because that means it would take a ton of drug for you to get to the toxic area, but you can stay in your dosage range for the therapeutic.
Yeah.
But the TCAs, tricyclic antidepressants, have a very narrow one. So that means the dose that you need to have to get therapeutic results will also likely produce side effects, toxic side effects.
Okay, I have a question about this, but is that also true for like, is it Advil or something that's like a common over the counter? But there's one that is like very close.
I don't know if it's Advil. Advil does, those are like the stomach ulcer, so all of the like
Okay,
NSAIDs and stuff.
That's
but I
just
don't
a side.
remember.
I have heard that, but it's one of those that you're like, oh, I never looked that up. But that one of them has like a very surprisingly low dose for it to be.
I don't know. That would be so cool. Because like another example would be like chemotherapeutics, which makes sense, right? Like you see these cancer patients that have toxic side effects all the time, but they have to because they need to get to the therapeutic dose.
Yeah.
But that'll be interesting to see which of the like over the counter ones it is. I wouldn't be surprised if it's an NSAID, which is what ibuprofen is. Those that treat pain, they're kind of wacky.
And then Tylenol does that similar thing, but for the liver, correct?
Well, but it's also the same for NSAIDs too. Like they're very similar, NSAIDs and acetaminophen.
Okay, so I feel another episode with Claire coming on.
Yes, yeah.
NSAIDs and anti-inflammatories. Those ones fun.
Wow, the wealth of knowledge you must have.
Oh my gosh,
this is gonna be neurochemistry for your life soon.
For my class, my pharmacology class, we learned, I think it was 437 drugs in total.
Oh my gosh.
And there's probably 30 plus classes. So all those drugs were within those like 30 classes. So we talked about heart, kidney. Kind of. We talked about GI. We talked about inflammatory. We talked about allergies. We talked about
allergies.
We talked about so many drugs.
Wow, that's
many
so fun.
drugs. And I have a giant Excel sheet that has all the information that we learned about all the drugs because I had to do it.
Export that to me. That'd be great.
Dude, I can because it's so interesting.
Okay.
So yeah, TCA is not given as much as SSRIs because it's pretty. You get these toxic side effects.
Okay.
They're not horrible. It's like dry mouth, constipation, blurred vision, confusion, tachycardia, which is a increased heart rate or like very rapid heart rate. They can also produce orthostatic hypotension. I love that word because it sounds like it's super fancy.
Yeah.
All it means is that when you go from either lying down or sitting to standing up, your blood pressure drops.
That happens to me, and I get lightheaded a lot when I stand up.
It might be a side effect of your drug, or it can just be something that happens to you.
Yeah.
But that can happen with tricyclic antidepressants as well. Okay. So not as prescribed as SSRIs, but can be given if a patient doesn't respond to SSRIs. SSRIs are first line treatment. They are prescribed first pretty much always, unless a patient has like a sensitivity, an allergy, whatever. TCAs would probably be next because of their efficacy. All right, the next one is monoamine oxidase inhibitors.
Whoa!
I know. Selegiline is the word. That's the like generic name. L-Dipril, that's the brand name. These are very not. This was the first antidepressant ever, actually. These were the first antidepressants ever, were these monoamine oxidase inhibitors. And they're good, but they also have some side effects. So they're indicated for depression and Parkinson's disease. I can get into that if you guys want, but I'll talk about depression.
It's a lot. I feel like Parkinson's.
It is a lot, but I am fascinated by Parkinson's. Like I am very interested in Parkinson's disease research. I work in a stroke lab. I'm also very interested in stroke too, but those are my two like very big research interests.
Wow.
It's so fun. So monoamine oxidase, it breaks down monoamines. So it breaks down serotonin, norepinephrine, and dopamine. So
I'm going to break in here and say oxidase sounds like it's an enzyme.
it is an enzyme.
And so the oxidase is like, does it do the oxidizing to break it down, something like that?
Yeah, it degrades these monoamines.
Okay.
So instead of doing the transporter here, we're just preventing the breakdown of these neurotransmitters.
Okay.
So that's what we're doing here. And it does have more effect on dopamine, I'm pretty sure. There's also these enzymes are also in your gut too, which that leads me into the most serious / kind of funny side effect that happens when you take these drugs. So it's called the cheese reaction.
Uh-oh.
So monoamine oxidase inhibitors, or MAOIs, they interact with a lot of other drugs and food. So tyramine is a compound that is in cheese, wine. It's in a lot of old food. So the older a food gets, the more tyramine that it has.
Got it.
That would be a fun episode just by itself.
I know, it would be fun. So MAOIs prevent the break, like they're inhibited, right? Like the monoamine oxidase is inhibited. That means tyramine can't be broken down. So that means you have excess levels of tyramine, which can cause a hypertensive crisis. So patients taking this pretty much should avoid cheese and wine and other
hypertensive crisis means.
I don't remember. That's all I remember learning in my class. And I remember writing it and I was like, someone's going to ask me, and I should have looked it up, but I didn't.
You said hypertension, something early about standing up, so it's a blood pressure related?
Yes,
reaction?
for sure. Yeah. I just don't know which way it goes.
They probably just explode. Like their blood pressure gets so
Like you're like,
high.
oh my gosh.
It's like a king toes that just, and it's like your blood just goes.
It reminds me of the guy in is it Inside Out with a little like anger guy and his like head is on fire. That's what I pictured.
Yeah, that's what happens when these patients eat cheese. And also, apparently, skin patches for these drugs work better. So they are given like orally, but skin patches work the best. And so, but they're pretty much not really prescribed anymore unless you have like treatment-resistant depression to other drugs. This is what's given.
Okay.
Because it's just kind of like it breaks down dopamine and serotonin and norepinephrine, kind of messing with a lot there.
Everything.
Right.
Yeah.
Yes. So like the less you mess with, the better. Even though you might get more effect, you're going to get more side effect. Like more therapeutic effect, you're going to get more side effect.
Got it.
So these can be, just because of the side effects and these interactions with a lot of different foods.
This is
drugs.
so interesting.
So when you say it breaks those down, that my first initial thought is like, that seems like a bad thing.
Well, so
Just I'm sure I'm misunderstanding something. there.
no. Like, so when the monoamines are like taken back up, they just need to be degraded so that there's not like excess of that neurotransmitter in the presynaptic neuron. Okay. Because it just makes more. Like it's going to make more dopamine.
Okay.
But in patients with depression or anxiety, for in this case depression, you already don't have enough dopamine. So it's like you don't want to break down the dopamine that you already have.
So it inhibits
the breakdown.
The breaking down.
Yes.
I see. Okay.
Yes.
It inhibits the enzyme that's oxidase that breaks down
okay.
the...
That's the piece I needed to connect it.
Yeah.
It's like a double negative kind of thing.
It is a double negative.
Yeah.
And so, like you said, when it comes to mind, like breaking it down in the initial, that sounds like it would be bad, but it's just good for like the regulation of the transmitter.
Totally.
Yeah. So, because you don't want to just keep, if you didn't break it down, you would just keep piling up dopamine or serotonin in the in the neuron.
Yeah.
And then things would go crazy.
Yeah.
Pretty much.
It's crazy that our brain can do all that. It's
I know.
We make it, we send it out, we receive it, we do something with it, then we break it down and
milliseconds.
A lot of people, we know exactly how much to do, but for some brains, there's like, it's not surprising that there's like needs a little bit of tweaking because there's so much to be doing.
It's also crazy that like there's things we have control over and things we don't. Like I can tell my body to do some pretty crazy things that are impressive.
Yeah.
But I can't be like, make more of this. Or like transmit more of this. You know, it's like, nope, can't do it.
Yeah.
And it's funny how like a neurotransmitter can do this like two things. It can do like a subconscious, like an unconscious thing, or a conscious thing. Like you said, the movement. Dopamine is a huge regulator of movement. For the initiation of voluntary movement, you have to have dopamine, and that's actually what Parkinson's is. It's you don't have enough dopamine, so you can't initiate the movement that you want to. But dopamine also does like reward stuff, which is very unconscious. Like like motivation, a very intrinsic motivation. So it can like, I need food or I need water because I'm hungry or thirsty.
I love these
like that's
chocolate
very,
chips, the way
that's
they
very
taste.
not like unconscious, but dopamine also does this conscious thing. So it's just crazy that it's doing all of these things at the same time.
Yeah, that's crazy. Wow.
Blows my mind.
Yeah.
That is amazing. I love learning.
Isn't it so fun?
This is why I started listening to podcasts in the first place. I was like, I can just sit here and do my life while people teach me things.
Okay, lastly, this last one. These are the benzodiazepines. So this is like your Valium. So that's diazepam. There's also Alprax. The other ones weren't as like familiar to me, but I feel like everyone knows what Valium. Like everyone's heard of Valium.
Yeah.
So these are used for anxiety disorder, seizures as well, and the management of alcohol addiction. So how this works, we're gonna bring back our GABA here. So remember, GABA chills out. So like makes it less likely that a neuron's gonna fire. So what benzodiazepines do is they bind to a benzodiazepine site on the GABA receptor.
Okay.
When they do that, it allows GABA to bind to its receptor more effectively. So instead of like activating the receptor, it just makes the receptor better, basically.
Okay.
Interestingly enough.
Can I go back to our original analogy to make sure I understand?
Yes.
So the GABA that's the thing that when you plug it in, it's like calm down.
Yeah.
So this is almost like you put an adapter on the plug where the wire goes to make it a better fit.
Yeah. Yeah.
Okay.
So it can inhibit better.
Yes,
Got it.
exactly.
Cool.
So it can inhibit better. So yeah. So that's how it works. So this is used for anxiety only.
Okay.
Because depression, you're already pretty down. So you don't want to be more down.
Yes.
Yeah.
Anxiety, you're not down. You're very like, so you need to be calmed down more.
Yeah.
But these drugs are kind of wacky because they are so like addictive. They have a very high abuse liability is what it's called. Very likely that you can get addicted to these drugs because what are called tolerance and dependence is really easily obtained for these drugs. So tolerance is that more of the drug is needed to produce the same like initial response that you had.
Okay.
And then dependence is that you need the drug to produce even a baseline response. So those not all the time lead to addiction, but those contribute very heavily to addiction. And so since benzodiazepines like work like tolerance and dependence develop quickly and they are very addictive.
I see.
They also increase dopamine in the reward systems. All drugs of abuse increase dopamine in your reward system. So benzodiazepines work the same way.
So you might get prescribed this for a time kind of thing instead of being like, all right, now you're on this forever. Because you will be addicted. Yeah. And you're very monitored. And this is also kind of like a last resort thing since SSRIs also treat anxiety. Yeah.
It's like, let's prescribe the SSRIs that are not addictive versus the benzodiazepines which are addictive.
Right.
So I was thinking like, I remember, I'm pretty sure, I'm not positive because I'm like a very good memory of like all drug names, but I'm pretty sure I was prescribed that for a specific procedure once, and it was like a very short number of days that I had it. It was like, but it sounded, I remember thinking like, I'm pretty sure that sounds like a hardcore,
like a street drug. And you're like,
but I'll just do what my doctor said. But anyway, that makes a lot of sense now that it's like very effective, but it has all these downsides. So here's 3 days worth or whatever.
I feel like for I've heard of people getting that for their eye surgery. Like, what is that called where you...
LASIK?
LASIK, yeah, because you kind of have to be awake, I think, for LASIK. And so people freak out. And so this is a very effective way to make people calm down.
But they're probably only given like 3 days worth. Probably not even that.
Right.
Yeah. So it seems like it's good for short term, but you wouldn't want to use it for like a chronic problem.
Exactly. Okay. And it's interesting that it's used for alcohol, the management of alcohol addiction. So alcohol actually also works at the same receptor. That's how alcohol works to kind of mellow you out, even though I don't really know, because some people who drink alcohol like go crazy, but alcohol is a GABA, like it works at GABA receptors and does like a very similar mechanism.
Interesting.
So it's the thought was that like, oh, I'm giving benzodiazepines to produce the same effect as alcohol does, but I'm not giving you alcohol, so you're not going to get addicted. But you're just giving something else that's also pretty addictive.
Yeah.
Barbiturates is another drug that works at the GABA receptor. That's also an addictive drug. So these are all drugs that are very addictive.
Dang,
So something about the GABA that just makes you want to take them.
Man.
That's wild.
So, but yeah, they work well, but not prescribed very well. And
just makes you want to like GABA it all up. You know what I'm saying?
Oh God.
And apparently the DEA has been cracking down on doctors who like prescribe this willy-nilly. So it's very like down on the list.
Yeah.
Just for like their practice. And
makes total sense.
for patients too.
Yep.
Okay, I got two more that don't really fit in. One is bupropion, which is Wellbutrin.
That's what I take.
And that's why I included it, because Melissa asked me a question about it. So this can be taken for depression and smoking cessation, so stopping smoking. It's also used for ADHD, which is off-label, and obesity off-label, actually.
Interesting.
So mechanism of action, when I looked it up, it said total mechanism unclear.
Classic.
So I was like, oh, great. But I went in my slides and we talked about it a little bit. It works very similar to SSRIs. So it blocks the reuptake, but not of serotonin, of dopamine and norepinephrine.
Okay.
Ayo.
So dopamine and norepinephrine are the ones that stay in the synapse this time.
Okay. Got it.
And it also blocks what are called nicotinic acetylcholine receptors, which is where nicotine binds. So the nicotine in tobacco, that's where it binds and does its effect. So taking this drug can block the effects of nicotine. So that's why you can take it if you're addicted to tobacco.
Because then you don't get the buzz.
Because you don't get the buzz. Exactly.
Trixie.
Wow, that is interesting.
It is.
That's
It
so
is. This is the other drug that has an FDA black box warning for suicidal ideation.
It does?
It does I think it's for like mainly for patients under 24, but it does have the black box warning.
It does not have that side effect in me, luckily.
That's great. That's
It just
awesome.
makes it easier for me to get up and live my life.
That's good.
Makes that dopamine more available, you know?
Yes, makes it more available because you probably don't have enough. So
I definitely
It kind of makes that dopa like mine. You know what I'm saying? You're like, this dopa's mine, dude. Like, I got this. There's plenty just for me. You know what I'm saying?
You can also have a lowered seizure threshold with these drugs. So, like people with epilepsy probably would not take this drug because they already have a lower seizure threshold.
Yeah.
Works pretty well. We just don't know exactly how it works, which is caveat kind of crazy to me that we prescribe drugs that we don't know how they work.
Yeah.
But they it's like I wouldn't want them not to be prescribed because they do work.
Yeah.
But why don't we know? And I don't like that we.
And
give
then
them
how
to
did
people.
we make it if we didn't know?
Yes, kind of scary to me.
Yeah.
But it's like there's so many drugs that it's like we don't really know how it works, but we know it works really well.
Yeah.
So I'm like,
That's so interesting. Wow.
I don't even know how. Lastly, I just want to give a quick shout to beta blockers like propranolol.
Oh, yes.
So these are mainly for like heart problems and stuff. So like heart attack, high blood pressure, but it can be used to treat anxiety symptoms. So because they inhibit what's known as the beta adrenergic receptor, beta receptors. That's why they're called beta blockers. And that's where epinephrine and norepinephrine bind. So like adrenaline. So that's causing your increased sweating, your increased heart rate when you're feeling anxious. So this is really good for like performance anxiety and social anxiety. It's not really treating the anxiety itself. It's more treating the symptoms so that you feel less anxious, but it's not the GABA, it's just the symptoms.
The adrenaline.
Which, the symptoms can probably contribute. It's like, oh my gosh, I'm really nervous to give this presentation. Oh my gosh, like I'm sweating. You can see my sweat. That makes me more nervous. So that just kind of gets rid of that.
Yeah, there are times I'm
so
like, I
interesting.
wish I could block that.
Yeah. So you said it's for heart problems as well? Like what's
that's
more?
That's the main thing because there's those beta adrenergic receptors are in the heart. So if you have high blood pressure, or if you had a heart attack, if you are just recovering from a heart attack, you kind of want to like stop the input to the heart. So that's why you're going to block those receptors. So you're just going to calm the heart down a little bit.
It's so funny because I've heard that term before, but I've wondered about that recently because during Robert Downey Jr.'s Oscar acceptance speech, one of the first things he said when he got to the mic, he's like, I popped some beta blockers earlier, so I'm just going to breeze right through this. And I was like, I thought those were like heart related.
Yeah, so he took them because he was nervous.
Yeah, I never went and like looked into it. Remember thinking like, so he doesn't have a heart attack? Or like, what? Like I was thinking like, it sounds like he's talking about nervousness and anxiety. That makes total sense. So it's like both. Yeah. I would never have thought those could be connected. It wouldn't occur to me. But
I also have a fun fact about that. I'm currently getting allergy shots because my allergies are really bad, which means I have to have an EpiPen in case you have a severe allergic reaction, and you can't have that if like the EpiPen, which works at the epinephrine, doesn't work if you're taking beta blockers because
it's the same receptor, so they're competing for that receptor. And they're blocked. They can't do anything.
If they're blocked, then your EpiPen doesn't save your life.
It's true.
Wow.
Well, those are all the drugs.
Wow.
That was amazing.
Yeah, absolutely.
Thank
That's a
you.
lot. There's a lot more there than I would have ever thought. I knew it was going to be complicated.
Yeah.
Because everything is. But that's crazy. There's a lot there. And the things that each of them have to do differently in order to have an effect is nuts.
Right. Or the same, but we can't give them because they have like bad side effects.
Yes.
Kind of
Yeah.
So,
wow.
It is very interesting.
That is so crazy.
Well, you knocked it out of the park. I have questions for you, and I feel like you also have some fun facts. I
did a lot of them already. Like I inserted them into my about the dopamine crossing the barrier, and then norepinephrine being direct derivative of dopamine.
Well, if you would be open to it, would you be open to sticking around for a bonus episode and we can ask a few more questions?
Yes, I would love that.
Great. Okay, well, let's wrap it up here. Normally we do like a fun thing to close out, but we can move that also into our bonus episode.
Yes, yeah.
Sounds great.
Okay, great.
Yay. Thank you guys so much for having me.
Well, thank you for being here, and thanks for sticking around for another bonus as well. And, if you have questions that have come up in your mind from this episode, of course, this is a totally new topic and a new area and required a new expert for this, but we'd love to hear your questions, and maybe we can bring Claire back for another episode in the future. So ask those as usual, or any other question you have, on our website at chemforyourlife.com. That's chemforyourlife.com, to share your thoughts, ideas, questions with us. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. You get perks, you get behind the scenes stuff, you get an ad-free version of the show, you get to join our coffee hours we have once a month, all kinds of stuff. You can explore the different options for you there. We'd love to have you as part of our Chem community and get to know you better. If you're not able to do that, though, you can still help us by subscribing in a favorite podcast app, rating and writing a review on Apple Podcasts or Spotify, or subscribing on our YouTube channel and leaving a comment on one of our videos, something like that. Those things help us to share chemistry with even more people, help us be discovered by more people who are looking for chemistry in their everyday life.
This episode of Chemistry for Your Life was created by me, Melissa Collini, her, Claire Caballero, and Jam Robinson. And Jam Robinson is our producer. This episode was made possible by our financial supporters, as Jam mentioned, on Patreon. It means so much to us that y'all are willing to give up your resources to help make chemistry even more accessible to more people. And those supporters are Jesse R., Sierra L., John T., Avishai B., Bree M., Brian K., Carol R., Chris and Claire S., Chelsea B., Derek L., Elizabeth P., Emerson W., Hunter R., Jacob T., Christina G., Katrina H., Latila S., Lynn S., Melissa P., Nicole C., Rachel R., Sarah M., Stephen B., Suzanne P., Timothy P., Venus R., Erica B., Cullen R., and Jeanette N. Thank you again for everything you do to make Chemistry for Your Life happen. And an extra special thanks to Bree, who sometimes creates illustrations to go with our episodes that you can see on YouTube.
And also extra special thanks to Claire for joining us. And if you'd like to learn more about today's chemistry lesson and all the drugs and all details, Claire's given us a long list of resources to put in our show notes and in the description of the video. You can go look at all those if you'd like. And
normally we say yay chemistry, but I think we should say yay neuroscience!
Yay neuroscience!
Yay Claire!